So, all right, so today we're going to go back and look at sequences. We've been talking about series. Remember the difference between a sequence and a series? All of the terms in the sequence to get a total. And a sequence, it's just an ordering of some terms. Okay. So we're not today. We're just talking sequences. And we're going to write formulas for these sequences again, but in a different way. I think that this is an easier way to write a formula for these guys than the other one, than the explicit way. That's what we were doing before. They're called explicit rules. A recursive rule is not about having some formula that you just have to drop a number in for n. A recursive rule is you drop in the term that came before it as what you evaluate with. Okay? The equation's really pretty simple. So I'll give you an example to start with. Let's say we've got a sequence -5, -2, 1, 4, 7, etc. So, can you look at this and tell me what the pattern is, what's going on? Okay. Everybody immediately says, +3. Well, guess what? In your formula, it's going to have a +3. Unlike before when you had to try and riddle out what you needed to have to put the number in and have it get what you want. This time, that told me is literally the equation for it. Okay? Now, it's pros and cons, which we'll talk about, but it's a different way to describe what's going on. Yeah?
Isn't this like the thing you said was really easy in Monday?
Mm-hmm. Yep. Just to help the formula is going to look, I'm just going to write out a few terms here, okay? So, 1 is -5. 2, you would get -5 and doing what to it? Okay. Okay. So you take -2, and that gives you 1. So, the next term in the sequence is always of what came before it. Okay? So in this case, continue this for a sub n. I did 1, 2, and 3, 4. What would be the term before a sub n? A sub n minus 1, right? It's just a notation thing, okay? When I was trying a sub 3, I needed to use a sub 2 to help me get the next one, right? Okay, if this is a sub 3 and this is a sub 2, a sub n, I got to go back, right? N minus 1. That's the only way I can really write that. It's just a notation thing. It just means the one that came before it. That's it. 1 less than 3. And 1 is 1 less than n. That's it. That's it. Okay? So, and what did we do with the term previous? That's the formula. To get the one you're on, you take the one that came before it, and you added 3. That's it. Okay? As soon as you can get past that little n minus 1, it's really not so bad. Now, it gives you, okay, because it doesn't exactly tell you where to start from, though, right? It just says, to get the next one, you have 3. Okay? I only gave you this equation and I said, okay, write out the sequence for me. Where the heck do you start? You know you're adding 3's every time, but do I start at, this actually was -5 where we started, but I could start this sequence at like 100 and then go 100, 103, 106, 109. it's not giving you exactly the same sequence every time, so you need a little bit extra information to really know what is the exact sequence we're talking about. So now we have, but you also need to include the first term. What's the pattern? What's the first term? Information to make the sequence then, right? So in this case, it would be a sub 1 is negative 5. So you got two things, okay? So the formula for it and the first term. So let me give you another one. What's the pattern? You're multiplying by 3 this time. Okay, so a sub n is going to equal what then?
A sub n minus 1 times 3.
Yeah, put the 3 in front because it's easier to look at, but you take the term that came before it and you multiply it by 3. Right? Again, a sub n minus 1 just means the term that was before it. Okay? What? Yes. Yes. No. Okay, and just like the last one, two. Saying. So this would be the whole formula for that one written recursively. Okay? A little bit. No. Now, arithmetic or geometric, there's little formulas you can use for those that work every time. Just think about it logically, like we just did these two without having any kind of formula for either one. It works. So, same time, you're always adding something to it, and geometric, you're always multiplying something to it. So, we can kind of generalize for each one of those.
Is there something for exponential?
There is, but we're not studying those. What is D? You guys remember? Okay. What was my common difference? 3. So I added a 3, right? What's the common ratio? Up there, the common ratio was 3. So what did I do? Multiplied it by 3. Okay, like, did you really need to know these two things? No, I guess not technically, but it's going to be the case, though. All right, so it's always, so one, you got to have the starting point, but then in addition to that, they always just follow this little pattern. Okay, so yeah, not such a big deal then that way. Your geometry. Now, if we have sequences that are not arithmetic or geometric, things get a little bit trickier then. Okay. So let's take a look at this sequence. This is actually a very famous sequence called sequence. And I bet if going on, I'll tell you guys can figure out what the pattern is. So the Fibonacci is 1, 1, 2, 3. It's called the Fibonacci sequence. I think so. Italian, I think. Okay. So, you guys all caught the pattern there? 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Okay, now here's the difference between this one and just a strict arithmetic sequence. We're adding things together, right?
Please,
Just a second.
interruption. We have a few announcements. Today is the last day to sign up for the ski club trip that will take place on Monday, January 26th. Bus will leave at 3:45 and return at 9:30. There's a $10 fee per person. You must be signed up and paid by noon today to be able to take this trip. So if you're interested, please take care of it at lunch. Thank you. Seniors, there's a survey in your email. Please check your student email and complete the brief survey from the survey. That is all. Thank you.
Perfect. So, the Fibonacci sequence is not arithmetic. There is no common difference between terms, right? The difference between them keeps changing. And the differences between them is based on the two terms that came previous, right? So you're not just using one term that came before, you're using the two in front of it. Okay? So if an equation or a recursive rule for this, what do you do with the two terms previous to get the one you're on? You just add those two together, okay? So if I'm on a sub n, what are the two that came before it? There's a sub n minus 1, and there's a sub n minus 2. Two previous, okay? So this formula looks like this. Okay? Means one term before, n minus 2, two terms before. Okay? Now, number in this sequence, the first one that has together to make. This one right here. Really, this formula doesn't kick into gear until you get here to the 2. Right? Now, before, we said you always had to say, what term does it start on, right? But this rule requires 2. I got to know the first 2 before I can start doing the Fibonacci stuff with it, right? I got to know what 2 am I starting with adding together, and then I can keep doing the rest of them the same way, okay? So while the other ones just needed an a sub 1, this one needs an a sub 1 and an a sub 2. Where are my first 2 terms? Because I need both of them to get the next one, okay? So a sub 1 equals 1, a sub 2 equals 1. You need all of that to describe this pattern. Okay? Does that make sense? Okay. So I'm going to give you another sequence. It's not going to be exactly the same, but it's going to be sort of like it. That's the guy that came up with it. It's his last name. So. You guys can get this one here. So I want you to see if you can come up with the recursive rule for this one.
And this one's Fibonacci.
And it
Is it Fibonacci too?
it does the same kind of thing, sort of, that Fibonacci does.
So we're going to have
What?
Use that equation.
No. It's not. And you're coming up with a new one of these for this.
I don't desire to do that.
Too bad. How do we do what? you can't, with those equations, what it allows you to do is to get the next one in the sequence if you know the ones that came before it. You can't just plug and then get one way. You have to take the time to get them. That's how they work.
So would these like work on tests instead of?
Depends on what I ask for. If I ask you for a recursive rule specifically, then yeah. If not, you got to do the other kind. Off for you and see if you can take it the rest of the way. I think at least a couple got it. A sub 1 is negative 3. A sub 2 is 5. Because I said it's kind of Fibonacci-like, so we need two of them to start with. What are we doing with those two numbers to get the third?
Flipping over, and then they're subtracting the first term by second term.
You're both kind of right. It's a subtraction, or you can think of it that way too. You're adding it, but then you're doing the negative flip-flops every time. Okay? Your formula, the easier way to write it is going to be just to say it's a subtraction. Okay? So, what is negative 3 minus 5? Negative 8. What is negative 8? Negative 8 minus 13. See how that works? Okay? You're right. Negative 3 minus 2 terms previous minus 1 term previous. Right? So this is going to be a sub n minus a sub n minus 1. So you got to go 2 back and then subtract one that's 1 back, and you get the one you're on. That's how that works. Okay, all relative to where you are. Okay, so just think about once you've got 6 people not even paying attention to what I'm saying at all. So look at where you're at. Like pick a number in the sequence that's kind of just a little bit like maybe the 13. 13 I did 5 negative 8. So relative to where I'm at, I did one that was 2 places back and subtract one that was 1 place back. All relative to where you were at, okay? So it's 2 previous minus 1 previous. Okay, and the little sign just tells you how far back they are from where you're at. Okay, if you get your heads around that, that's really the crucial part of this. Is these little subscripts just tell you where you are relative, or where these are at relative to where you're sitting right now. Okay, so it's 2 back minus 1 back, n minus 2, n minus 1. That's how you describe that then. Okay, and all that is a notation right now. Okay, so the other thing that we need to do is to translate between recursive and explicit rules. Kind of make explicit's what you've been doing. Okay, so just so that we can have the ability to get back, because I might want one or the other type of sequence. So being able to do that, and this really isn't all that difficult. What? So, on this. Point then to recursive rule and an explicit rule. Explicit rules are what you've been doing so far. So an explicit rule is one where you would plug in to get the term. So that one, these are actually pretty powerful because if I wanted to know like the 500th term in a sequence, all I'd have to do is take 500, plug it in for n, and I'd get it. Recursive rules don't work that way. Recursive rules, you don't plug in n, you plug in the term or terms that came before it. So recursive rules are kind of nice because they're easy to make, they're easy to understand when you look at them, but if you want a term that's way down the line, you got to go one step at a time. You got to get every single term up to the one you want. Because you have to keep playing what came before, what came before, what came before. And so it takes you forever to get up there, okay? Doing a recursive rule. So the recursive rule, you plug in n minus 1 or a sub n minus 2 as well, if it's Fibonacci-like, to get the next term. Okay, so a recursive rule is kind of like a slow trudge through the sequence. Explicit is you get right to what you want right away. Okay? So if it's written as an explicit rule, how do I turn it into a recursive rule or vice versa? Okay? And the easiest thing to do is going to be figuring out, number one, is it arithmetic or geometric? And once you have it, can you make the sequence and then go the other way with it? Get to the other type of rule that you want. Rule. A sub n equals I keep using 3, but whatever. And then a sub 1 equals, let's say, we'll start at 10. Okay? So I want to take this and I want to write the explicit rule. Well, think about the common link between stuff here. The sequence itself. If you could write out the sequence itself, you could do this. Think about the explicit rule. What do I need to know about the sequence? Not sneaky at all. Fail, big time. So you need to know the first term, and you need to know what the common difference is, right? So a sub no. And what is the common difference in this particular sequence? 3. Okay. So if you wanted to, you could write out the sequence. If you go back, and maybe you need to check out your notes to find sequences, we have a little formula for those that we used before that we will bring back. That looks something like that. Does that look familiar? It should. Okay. We're doing these. The only two things that we needed to write an equation in this way was a sub 1 and d. Plug them in. So, yeah, once you know it, first term 10, n minus 1 times the common difference is 3, and then it was just a matter of distributing, simplifying, all of that kind of thing. So then this becomes a sub n equals 3n, let's see, that would be minus 3 plus 7. Yeah. So going from to explicit is not very difficult because right in the formula for recursive, you have the first term and you have the common difference. And it's just a matter of lifting those out of there and plugging them into that little formula that you already know and doing it. Okay, geometric would be the same thing, right? You got that little formula for geometric. You would take the recursive formula for the geometric one, find the common ratio, first term, take them out, formula for that one, got it. Okay? So I'm not going to do geometric that direction. It's a little bit more challenging. Split recursive. So let's do that real quick here before we finish up. All right, we got. So for this one, I would like you to write the recursive rule.
For how easy you make this out to be, there's a lot, right?
Yeah. Other direction. I'm still sticking with arithmetic for now. Rule for this explicit rule. So I'm going to use that same little concept that we talked about, that if I know the difference, I can then write the other one, right? I just need those two things. Okay. If this is my explicit rule, plug in a 1. Okay. So 1 minus 1. Okay. We got that. And what's the common difference? It's the 5, right? The coefficient on n should be the common difference. So boom, I got what I need. I got my first term. I know I'm adding 5 every time. So can we write a recursive rule if we know that? Absolutely. Okay. So a sub n is going to be equal to the previous term, a sub n minus 1 plus 5. Difference. That's what we add to each one to get the next one, right? So that's how that formula would look. And then with recursive, we also need to have the first term as well to know where we're starting from. Yeah, don't forget that. Your recursive rule includes both those two things. Use geometric as well, though, just so you see it. Okay, so we'll do the geometric and then we'll be done. So a geometric recursive, or I'm sorry, explicit rule. So let's say I've got a sub n equals, would be a good geometric one, -3 times 1/2 to the n. And same directions, we're going to write the recursive rule for this explicit rule. But again, we only need those two things again. We need to know the ratio this time and the first term. Yes. So, what is the first term? Should be -3 times, it's supposed to be n minus 1. Duh. Try again. What's the first term? -3, yeah. Yeah, those always have n minus 1 on them. So -3, and you know the ratio, but that's always whatever's in the parentheses here, right? Based on how these things were put together when we did them. So r is 1/2. So if we know the first term and we know the common ratio, we can make a recursive rule for this then, right? Okay, so a sub n equals 1/2 times a sub n minus 1 then. It's half of the term previous every time. And then we also need to include the first term, which was -3. Got it. All right. See how you do. Yep. Give you some homework time here.